Hello, wonderful AP Bio students. This is Miss Ewing, and welcome to your video on ecosystems energy. What we're going to be looking at, we know a lot about ecosystems so far, but we need to study this energy thing. And primarily, we need to study how energy moves through the ecosystem, right? This is going to be our system that we're studying, and how it's recycled and how efficient it is as well. So we're going to be looking at the different players, how it all fits together, and it should be fun. I like this one. All right, let's get going. The first thing I want to talk about is how organisms on Earth are classified as either producers, which would be things like plants, and they use a process, which I'm sure you've heard of, called photosynthesis. Photosynthesis to produce biomass. And biomass is just basically living matter that has mass, living stuff that has mass. So it takes energy from the sun and carbon dioxide and water and nutrients from the soil, and it creates leaves and flowers and pine cones and pollen and stems. So it's a producer. It's taking inorganic things and turning them into organic things. Then we have, when we switch colors for this, we have consumers. And consumers use the process of cellular respiration. And that is basically taking what is made through photosynthesis, consuming it, right, consumers, and breaking it down for energy, and its waste are those inorganic products like the CO2 and water as well. So these are the two players that we have in ecosystems, producers and consumers. And we're going to go a little bit deeper. We're going to first look at these producer types. Producers are classified as autotrophs. Now, auto literally means self. So auto means self. Doesn't look like an E, self. And troph means nourishment. I'm not even going to try to spell that one. So it's self-nourishment, basically taking the inorganic things and making themselves out of it, right? So a plant takes carbon dioxide and sunlight energy and water and makes itself, okay? So when we look at autotrophs, we can kind of classify them into two different things. We have photoautotrophs, which are these guys right here. I'm going to put a little dash here because I can't fit it. And photoautotrophs are simply organisms that obtain their energy from the sun to convert the inorganic molecules into organic molecules. And they do this through photosynthesis. And photo, this word right here, means light. So they are giving themselves nourishment, and their energy source is the light. The next type of organism I'd like to talk about is they get their energy source from a place that's a little bit different. They're called chemoautotrophs. Chemoautotrophs. And they obtain their energy through available chemicals. Maybe they live in an area where the sun, they cannot get this energy from the sun. So they have different chemical reactions happening in their environments, and that's where they obtain their energy. For example, this is a deep sea vent right here. And it's at the bottom of the ocean, no sunlight, really, really dark place, not a lot going on there, except there's these organisms that have evolved to use their energy source as methane. So they use methane coming out of these deep sea vents as their energy source, and they're called methanogens, and they're part of the kingdom Archaea. They're found in deep sea vents, and there's entire ecosystems based off of these bacteria, basically, that live off of methane. There's also they're called extremophiles often. They live in places where light doesn't occur. We have different autotrophs that get their energy from oxidizing sulfur or reducing sulfur, from nitrifiers or halophiles. So There's a lot going on over there, and it's really interesting to understand that there's very unique, very rare organisms that get their energy from a place other than the sun. So let's talk about consumers. Now, consumers are called heterotrophs, okay? This right here is a zebra, or in England, they'll call it zebra. Basically, everywhere else in the world that speaks English, they call it zebra. And a zebra is a heterotroph because it consumes other things to give itself energy and to make it grow. A zebra consumes herbs, right? It's an herbivore. And the thing about herbivores, they're consumers, but we call them a primary consumer. A primary consumer is an organism that feeds directly on a producer. So an organism that eats plants, basically an herbivore. So that's one type of heterotroph. Let's look at a second type of heterotroph. I have a lion, and there's our zebra from the last slide. A lion, as you know, is a carnivore. And it's a consumer as well, right? It's a heterotroph. It obtains other things for its energy. A lion can't sit out in the sun and be like, oh, I'm making food, right? So heterotrophs, lion, consume meat, right? Carn, meat, for its energy. But the thing is, have you ever seen a lion munching down on grass? No, lions eat only meat. They're actually called a secondary consumer. Which basically means they consume the primary consumer. So they are eating the zebra, which is eating the grass. Okay, secondary consumer. Then we get a little more complicated. Here we have a hawk. This is a hawk. And this hawk is eating a lizard. Poor little guy. There's our lizard. And what does a lizard eat? Well, a lizard eats bugs. Here's a bug. Okay, not pictured, but that's our bug. What does a bug eat? Well, a bug eats plants. Okay, so in this situation, the lizard is the secondary consumer. The bug is the primary consumer, and the plant is the primary producer. So that would make this hawk what we call a tertiary consumer. Let me see if I could spell this right. Tertiary. I think maybe that's an E. Oh no, you guys can double check for me. Tertiary consumer. Okay, something that eats something that eats something that eats grass or plants. Okay, so let's take a look at this and put it in in some context. Okay, before we do that, we need to figure out how all this stuff gets back into the system. And how it gets back into the system are through not producers or consumers, but decomposers. You can also, sometimes these are called detritivores. Detritivores. And they obtain energy. They're still a heterotroph, right? Because they are obtaining energy through breaking down bits and pieces of dead things, which is detritus, okay? So they use little bits and pieces of dead things into even smaller bits and pieces of dead things, and smaller until those nutrients can be recycled back into the system at the producer level. It's kind of the circle of life. So the decomposers are what bring everything back and give the nutrients back to the producers. It's a circle of life, right? And it moves us all through despair and hope, through faith and love, till we find our place in the path unwinding. One of my favorite movies. Anyway, let's move on from being distracted and talk about the circle of life. Well, ecologists, we see ecosystems, they're not linear. However, when we look at energy within an ecosystem, we put it in not a circle, but in kind of a triangle, on a weird looking triangle, like a pyramid, okay? So let's take a look at this. Now, this pyramid, let's see, me get there we go. So this represents energy level, okay? So here we have energy. I'm going to put an E for energy. And if we look at the base of this pyramid, we're going to have our first trophic level. Now, it's going to be easier for me to go through each trophic level, and then you can kind of understand what a trophic level is. So here we have our first trophic level, the thing that fuels us all, and that is the primary producers. Primary producers. There we go. These are the things that go through photosynthesis. And after we have the primary producers, what do we have next? Well, we have the primary consumers. I'm going to put P, consumers. And then after primary consumers, we have our secondary consumers. And then sometimes we'll have a tertiary consumer. And this little box on top, this right here, is our decomposers. And they give the nutrients back to the bottom of the system. So here's the deal. Let me explain why this pyramid looks so funny. It's not a perfect little pyramid. There's this thing called the 10% rule. And this has to do with energy. This doesn't have to do with biomass or number of individuals. We're just talking about energy. So the 10% rule is every trophic level you move up, only 10% of the energy from this trophic level moves to the next. That means 90% is lost, and it's lost through waste, cellular respiration, heat. Okay, so the thing that gives most ecosystems energy is sun. So the sun's going to give a certain amount of energy. The primary producers use that energy to grow and create themselves, right? They're autotrophs. And then 10% of that energy is passed on consumers. And then 10% of that original 10% of energy is passed down to the secondary consumers. Let's look a little bit deeper into this. So let's put some numbers to this. So if there are 1 million joules of sunlight, okay, joules is a measure of energy. So if we have 1 million joules of sunlight in a system, this is our ecosystem, right? Our hypothetical ecosystem. We have 1 million joules going in. 10% of that, which would be 10,000, can move into the primary producer's trophic level. Okay, you with me? So we have 10% of that energy is actually moved into the primary producers. Now we have 10% of that energy can be moved into the primary consumer level. So we only have 1,000 joules. 10% of that to secondary consumers, which is 100, and 10% of that to tertiary consumers, which is 10. So you can see in a system where there's 1,000 joules of sunlight, the tertiary consumers only really have access to 10 joules. Okay, that's why we don't see herds and herds and herds of tertiary consumers, because there's not enough energy to support them in an ecosystem. Let's break it down a little bit more. Okay, so let's look at at one little guy. This is a caterpillar. What do caterpillars eat? They eat leaves. So a caterpillar is a primary consumer. Let's say that the caterpillar eats 200 joules worth of energy from the plant. Okay, 100 joules would actually come right back out as poo. Feces, we say in biology. Feces. Okay, so 100 joules comes in as waste. So about half of what you consume is not even used. It comes right back out as waste, right? 67 joules would be used in cellular respiration. Cellular respiration. Okay, so 67 joules cellular respiration. This is what gives this caterpillar energy to move around, to mate, to eat. And it's also, a lot of its loss is heat. All right, so that leaves us only 33 joules would go towards growth and development. Now, only this growth and development would be passed on to the next trophic level. So all of this 200 joules, right? 33 joules would go in towards growth, and that would then be eaten by a bird, right? So that would be going to the next trophic level. We're gonna have some practice with this, so this is feeling a little fuzzy. You'll be sure to get it soon. Okay, so there's a few questions I have for you guys and want you guys to think about. The first one is, who is the most efficient user of their energy source? Okay, so they all use 10% of the next, but our energy source is sun, right? This is our primary energy source. So the trophic level that is using the sun most efficiently would be the primary producers, okay? Another question I have for you is, or I just want you to think about, is sun enters the earth at varying intensities, right? The sun is more intense at the equator, less intense at the poles. So I want you to think about what that means for the ecosystem and available energy for those places. And think of the equator, right? You think of tropics, you think of rainforests, there's tons of life. Well, there's a ton of energy pouring into that system, right? If you look at the poles where there's not a lot of life, it's a frozen ice tundra, right? So there is less energy pouring into that system, so there is less availability for these trophic levels. Things to think about. Another thing you should be used to seeing is what's called a biomass pyramid. And this is another pyramid. However, instead of looking at energy, it's actually looking at biomass. So this is like if we took everything in that level, so this is our primary producer level, and we chopped it down, right? And we weighed it, okay? That seems like a crazy task. Then it would move in a pyramid just like this. So we would have a larger mass at the bottom, and we would have a lighter mass, less mass at the top. So as we move through trophic levels and through our different producers and consumers, we actually see less and less and less of them. That's why a herd of lions is much smaller than a herd of zebras, right? So what's interesting though is in an ecosystem, things aren't very linear, right? We don't say, okay, this eats that, which eats that, which eats that. Well, it gets a little crazy, and we can form these things called food webs from it, okay? Because we have different organisms eating different organisms. So if you look here, we have our primary producer, and I am going to go ahead and put a circle over our primary consumer. So a primary consumer is something that directly eats the producer. So a grasshopper eats the plant, the rabbit eats the plant, and the mouse eats the plant. Now let's take another step. Let me do a different color here. So I'm going to put a black circle around the secondary consumers. Okay, so secondary consumers is something that eats a plant. All right, so our lizard here eats a grasshopper that eats a plant. Our snake here eats a mouse that eats a plant. And our hawk here eats a rabbit that eats a plant. So these would all be considered secondary consumers. Now it gets a little dicey when we're looking at the hawk, because look at this. The hawk also eats a lizard that eats a grasshopper that eats a plant, right? So the hawk is also a tertiary consumer. So this would be tertiary. I'm going to put 3' for tertiary. These would be primary consumers. And where's the black? There we go. This would be secondary consumers. Okay, let's get a little more complicated here. What I would like you to do for this next one is I would like you on your page to either list or put a box around, if you have this printed out. I would like you to put a circle around the primary producers. I'm going to put primary producers. I'd like you to put a star next to the primary consumers. I'd like you to put a box around the secondary consumers. And let's see, how about a spiky bubble around, so a primary, secondary, tertiary consumers. And if there is any quaternary consumers, I would like you to put a big Q on top of them, okay? So this is for our quaternary consumers. So take this web, it's a little more complicated than the last one, and really look at it. The arrows show that, so if there's an arrow showing going from the plant to the rabbit, that means that that plant is giving energy, giving 10% of its energy that it has to the rabbit, okay? All right, this is a really simple food web. Things get a little crazy, especially in the ocean where animals have more mobility. So this is just actually a simplified ocean food web, and you could see that, yes, the sun gives energy to all food webs, mostly, but a lot of this food web centers around a krill, right? And the krill is the species that kind of holds everything into place. So when we study ecology, it's important to understand these species that give energy to a bunch of different trophic levels, because if we overfish, or if something or climate change happens and this species becomes endangered or extinct, then you have a whole interconnected food web that depends on this species for its energy. So let's review. We talked about a lot in this. In review, we have life is characterized as either a producer or a consumer. And in producers, we have autotrophs, which means self-nourishment, and they are the primary producer for the ecosystems. They produce the most biomass as well. Then we have consumers, which are heterotroph, which is things that consume things, right, for energy. So we have primary consumers, secondary consumers, and tertiary consumers. And then we have decomposers that break down all the detritus and give it back to the system, basically give nutrients and compounds back to the system. So once we understood this, we talked about how energy moves through these producers and consumers, and we talked about the 10% rule, how only 10% of the energy produced or used in a trophic level is able to be passed to the next trophic level. We also looked at biomass pyramids, which is a pyramid very different than energy pyramid. Instead of showing the amount of energy, it's showing the actual amount of mass of living things in that trophic level. And then we kind of talked about how eating things isn't linear, and that everything is actually an interconnected web. Now I have one more thing I want to show you in this video, and that is some deep pondering questions. So answer the following questions at the bottom of your notes, and these just need to be quick little answers. They're kind of food for thought. So number one is kind of simple. What trophic level is the most efficient energy consumer in the system? The second one is, why is it ecologically a bad idea to eat lions? So why, if all of a sudden America decided to have this delicacy of lion meat, why would that be a bad idea for ecosystems? And the third one, for this question, you are a hypothetical vegetarian. So hypothetical, don't freak out. This is make-believe. You don't have to be a vegetarian. I want you to explain to an omnivore friend, so a friend that eats meat and herbs and vegetables, why not eating meat can free up more energy for the system. And that concludes our very long but very informative video on ecosystem energy. Have a great day.